Wow. Welcome, team Sewers4Covid. It's great to have another chance to discuss your brilliant proposal and your project. So we have Lewis here. If we start up at the right, we have Lewis, and then we have Frederick, and then we have Mehdi. So team Sewers4Covid, we want to know more about your project, more about your experience, and the testing. This is very interesting, how you're going to get this data out of the sewage.
Yes, maybe let me start about that. So the whole idea and the principle relies on the fact that people that are infected by the virus that is causing the COVID-19 outbreak actually shed or release the virus through their stool or the feces. This means that if you're collecting wastewater at a wastewater treatment plant of a city, for example, you can actually measure, you can detect and you can measure the virus that is present in the wastewater. And this is done using molecular techniques, and it's called quantitative real-time polymerase chain reaction, or qRT-PCR, to put it short. And the technique allows to detect and quantify the genetic material of the virus. And it's being used for clinical testing, but it's also a technique that has been used for environmental testing of pathogens, also in water, for example.
This is very interesting because I've read something about how this type of testing, the RT-PCR testing, is really the only viable way to detect living pathogens in water systems. Do I understand that correctly?
Well, it relies on the detection of the genetic material. There are nuances. There are also other techniques to sequence the entire genome or the entire genetic material of the virus. But this is one of the techniques that is being used, and so far it's being used for this particular purpose. And you can also add a quantitative part to it, so you can actually count, if you want, how much genetic material there is in the sewers. And by following this genetic material, the quantity of genetic material over time, and that's where the sewer analysis becomes particularly interesting, you can follow trends in terms of the amount of virus that is circulating in the population. So this is particularly interesting. This is where sewer testing can be very useful, because by collecting samples at a wastewater treatment plant, you can have an indirect indication of how much virus is circulating in the population that you're testing.
So could we go upstream from the sewage treatment plant? Let's say we have a neighborhood that is being afflicted really severely by COVID. Is your solution the type that could be deployed in other areas in the sewage system, not just at the treatment plant?
Yes, you can go upstream. This is more a logistic question rather than an analytical question. So the technique, the monitoring, the detection of the genetic material remains the same. It's more of a logistic question in terms of where do you go and collect the samples. So you can do this in manholes, so in the sewer itself. But it's logistically more complicated, because what we're doing right now is that we're relying on infrastructure which is already present at wastewater treatment plants, because they collect wastewater already, and they have to do it because they have to comply with environmental regulations. So the infrastructure to collect samples at the treatment plant already exists. Well, if you want to go upstream, you need to place so-called auto samplers that are being used to collect the wastewater samples. So you need to place them. So this requires a bit more of logistics. It's a bit more complicated, but it's feasible. It's not being done in this particular case yet, but it's feasible.
So Frederick, you have two other team members with us today. We have Lewis and Mehdi. So how are they supporting you in this project, or how are you, the three of you, working together? I'm sure people watching are very interested in this.
In my case, from EURCAT, we have contributed on the data science part. And based on the sewage analysis that Frederick has introduced, we try to apply artificial intelligence to understand the relation between the quantity of virus that can be found in the sewage and the number of real infections. And based on that, we will implement the intelligent models, which will give us real-time predictions. Okay.
Interesting.
On the side of putting things together, we are living in the era of digitalization, and you've got all these layers of information on top. So it's not enough to just get where the virus is before it comes. It's kind of useful to add a stack of data about who's vulnerable in the area, who needs help. You know, you can gather all this data economically, socio-economical stuff, everything, and then you can start inferring different degrees of intervention with the resources you got. So in a way, what makes it interesting is the major challenge of every single digitalization thing going on at the moment. What do you make with all this data from different layers, and can you put them together to try to answer that question? And this is where, you know, you can measure the viruses in the sewers. You know where the elderly are. You know where the vulnerable are. You know, you can extract in advance how many masks you might provision for the hospital, or how many gloves for this particular area. So this is where it comes in.
So could your system be expanded to account for emerging comorbidities? For example, could I expand your testing and look for, from what I understand, tuberculosis is a comorbidity that's surfacing. Like, could we expand the testing? Can we look for more than just COVID with your system?
Well,
That's
from the testing
point.
perspective,
Yeah.
Sorry, go ahead, Mehdi.
Just the general idea is to be expanded for other type of viruses and things with different genetic materials. Doesn't have to be only COVID.
So that means you're creating a solution that is scalable for the future, because this will not be the only type of event like this. We're going to have more.
Hopefully not, but yeah, it's likely to be. So better be prepared.
So this is a really international grouping of people. So can you all tell us where you're from? Because it's a beautiful mix that really shows what Europe is all about.
Well, okay, I'm French. I live in the UK.
I am Swiss and
From
Swedish
Spain.
and live in the Netherlands.
I'm from Spain.
Luis? See, in Europe, it's baked in that you have an international perspective and multicultural, multinational perspective. So do you have any messages for people that are thinking about getting involved in hackathons or in any type of movement like this to inspire them?
You don't need to be a computer wizard or to know everything about coding. Everything can bring something on the table. Doesn't matter what it is. It might be just copying, pasting text, browsing the internet, anything. As long as you want to contribute, it works.
Well, thank you very much, Team Sewers4Covid. We really look forward to the progress of your application, and we're not wishing you luck, because our job is to match you with the upcoming Matchathon.
Yep. Thank you very much.
Thank you.
Let's just hope we're all successful.
You already are successful.
Thanks.
Thank you.